Welcome. Lots of people interested in geometry nodes, I see. I'm glad you guys all made it, even though it was a little bit tight on the time. But right, so you can see we're already in Blender. This is going to be a little bit of a mix. I wanted to not do like a step-by-step, okay, here's how you do X thing tutorial sort of thing, but rather more of a display of like the broad variety of things that you can do in Blender. Of course, also explain some things, and we're in Blender, so we're going to also create some things, but the focus that I want to give is on the variety, also on geometry nodes. All right, first thing, a little bit about me. I work at the Blender studio since the beginning of 2020. I've been working on these projects that you can see here. And since the beginning of the development of geometry nodes, I've been part of the core team since we started in the end of 2020, part of the development cycle from the artist side of point of view. And in general, I just like procedural workflows. I've been using procedural shader nodes for a while already, and then geometry nodes, I jumped onto using them for every single thing that I can do them with. It's like the first idea that comes to mind, can I do that in geometry nodes? And that brings me to talking a little bit about the title. We can do that with geometry nodes. That sentence has been kind of developing as a little bit of a catchphrase of mine at the studio, because for those that have a little bit of production experience in a production environment, you always have issues to solve, right? There's nothing ever goes perfectly smooth all the time. And whenever we have the dailies and are talking about, okay, how can we solve this specific thing? There's usually, I think about it a little bit and I'm like, yeah, we can do that in geometry nodes. And that's what I want to talk about a little bit and give a couple of examples where we solve, we do problem solving specifically with geometry nodes in our productions. Right. Okay. Because I'm going to do a little bit of practical work, I want to bring everybody a little bit on the same page. I don't know, there's probably a really broad variety of experience levels with geometry nodes in this room right now. So I want to at least give a little bit of theory, even though it's not the most popular thing. And the most important part to understand about this is what even is geometry. Defining that is already a pretty important thing in understanding, okay, how can I work with it on a node-based system? And my broadest, most general definition of that would be it's just 3D data that has a certain meaning, right? Everybody knows about meshes, and then there's volumes, but it's all just data, and it has a certain meaning in the 3D environment that we're working on it with. And you can convert between different types of data and propagate different properties of these types of geometry. And within that definition of geometry, there are different types, of course, of geometry, which in geometry nodes we call components, because those can coexist within a single geometry right next to each other. So you can have the geometry as a container that has meshes, curves, volumes, whatever, inside of it as components at the same time. And that's very useful because that makes you very flexible in working with them back and forth. And then on top of these components, there are domains which carry the actual data. And that's the reference frame for the data. For example, we just open up a spreadsheet editor here so we can take a look at this. Okay, I need to actually find an object. Here you can see the different components, right? We have the mesh, curves, point clouds, volumes, instances. Those are the ones that we have currently. And then underneath that, you can see that we have the domains. So a mesh has a bunch of data on different domains. Vertices have their position as data layers. So you can see every single vertex of this cube that I just added. Where is it? Oh, there it is. And then edges have other sorts of data. Currently, this one doesn't have any, but it makes sense to store within the geometry, depending on what type it is for the mesh, to store data on different frameworks, because vertices have a different use than edges and faces and face corners and so on. And understanding that is already quite important to get a good understanding of how to work with this. But I come back to these points later on while we go through the examples. I just want to give a broad overview in the first place. Right, and then the data layers that are inside of these domains are called attributes. And attributes are a more generalized way of describing what you already know as like vertex groups and UV maps, that kind of stuff. It's just the layers of data that are stored on top of the geometry inside of the domains. And then in geometry nodes specifically, because that all needs to be visually represented with nodes, we have the concept of fields. And fields are basically just a representation of attributes and operations on top of these attributes for nodes. So they are not actually carrying any data themselves, they're just a representation of an attribute. I'll go into more detail a little bit later. Right. Okay, I already mentioned this a little bit, but for the examples that I want to show and go into a little bit detail here and there, are mainly supposed to showcase what I noticed, especially looking back at the production experience that I got from the past 2 projects where we used geometry nodes heavily on. Just showing the broad variety of not even just the use cases themselves, but even just the types of tasks that we were able to tackle with geometry nodes. And I'm going to lay a big focus because of that onto the problem solving and a production environment. And because I wanted to show so many things, keep in mind, time is a little bit limited, so I can't go into detail of everything. I'll try to go into detail with the more simpler examples. And then the more advanced ones, just sketch out in broad strokes so we get the idea behind it. And then maybe focus on 1 or 2 nodes that need more explaining. Right. Okay. Looking back at the examples that looking for the examples that I wanted to showcase in this presentation, I basically just made a list looking at all the different use cases that I could remember from Sprite Fright and the current project Heist that you're gonna see the work in progress in the during the Cezanne Awards. And it's been a lot of different use cases, and I kind of started noticing a little bit patterns where we had different kinds of tasks. And one of them, which is something that's really applicable for production environments, but also for individual artists in general, is just using it for the attribute pipeline. So the data on top of the geometry is something that's very universally used in Blender already, as I mentioned, with the legacy types of attributes that we have with vertex group, etc. And with geometry nodes, it's only growing and getting more general. And you can also use it, for example, in shading. So some example that I have here is, it's left click select. I'm sorry, I have to change that. All right. So this example is edge detection. That's something that's incredibly useful for procedural shading. Everybody knows about it. The way you do it for the different render engines that are in Blender is not consistent. Eevee does it differently than Cycles. Nothing is really optimal. But it's all just analyzing geometry data, right? You just want to get information about the geometry, about the angle of the edge, basically, into the shader. And you can do that with geometry nodes. So here, I just have a single, very simple geometry nodes modifier where I can just adjust the strength and a general offset to the edge detection. And it works on an object level. So if I duplicate the object, I don't have all the control parameters baked into the shader, but can actually change them depending on the object. And that's really powerful. And as I mentioned, the setup is really simple. So this one, I'll just recreate really quickly. create a new geometry nodes modifier. And then here, just add an edge angle node. And this is basically going to be the core of the edge detection. It's all about just the angle that an edge has between the usually two faces that it is connected to. And to get information about both directions, whether it's in this way or this way, I need to get the signed angle, so get positive and negative values. And that can already just be dragged to the output. And just going back a little bit to the theory part, this input node gives me a field, which is a representation of the edge angle. And then as soon as this field here is output together with the output geometry, it attaches a new attribute on top of the data of this geometry. So the actual data, that's a little bit abstract to understand, but it's an important point. The actual data is not in this node or in this field here. It's only in the geometry. That's why the line up here is solid and this one is dashed. And also the socket shape tells you whether it's a field or not. But the important point really is that the actual attribute, the actual values, the data that you see in the spreadsheet is only created whenever it's used. Before that, it's just the abstract representation of the edge angle. And that's pretty useful because now, without even knowing the values, just knowing, okay, this represents the edge angle, we can do some operations like just adding a math node and multiplying it with some value. We can just expose that. And then this is going to be the scale. And adding another math node, setting that to add to give the whole thing an offset. Put the default to 0. And then, oh yeah, it doesn't work yet because we need to actually name this attribute. So right now, no attribute is created because it's not being used. But if I just call this edge mask, which is exactly what I'm using in the shader, you can see that now it works. And the way that this works in the shader is really simple. Let me just go to this tab. You can see there's the attribute node, which I recommend just searching. There it is. And then you can just type in the name and you get the mask. So for the attribute pipeline part, this is incredibly powerful for any type of workflow. Just getting information about the geometry in any way that you can actually get it with the nodes that are available, which by now are quite a lot, into the shader. Or sharing it between other objects. There are different use cases for this also. One more I want to show about this specifically. I can't go into that much detail because it's a little bit more complicated. But I can show a little bit of the very basic of this example. Stretch maps. So here I have a setup where the deformation of the sphere creates a directional stretch map, which then in the shader is picked up to use the direction information and then the tension of the deformation to generate a directional wrinkle map. And there are multiple parts to this. I'm going to go into more detail in the blog post, hopefully soon on the Blender Studio website, but essentially how this works is that I'm storing information about the base shape before it's being deformed, and then comparing it later on with the state after it's deformed to get the information of what changed, and thus I can generate a tension map to see, okay, this one was compressed, this one was stretched, and then figure out the direction. Yeah, I mean, can maybe show. Yeah, so this setup is a little bit more complicated, but I will create a very simple version just now. So here I have a modifier that does the deformation, so I don't have to do it in sculpt mode. And one thing I will do here is before that deformation in the modifier stack, I add a modifier, which only does one very simple thing. It uses the face area as an output. And then here, I just store it as the rest face area. And now it's part of the geometry data. And these values are not going to change because it's an attribute that is completely disconnected from its initial meaning. It's not a face area anymore, it's whatever the values represent. And those values are not changing anymore. And then after, so this is the deformation. Afterwards, I just create another modifier. And in this one, I also use the face area input. But because this here is not actually, it doesn't have any connection with the attribute I just created, it still represents the actual face area after the deformation. I can compare these two. Just use a divide node. Oh. And then just get an input from here. And then here in the modifier inputs, I can press this button to actually put in an attribute, and it already shows up here. I can use the rest face area. And then I can output this, and this is going to be the ratio between the area after deformation and before deformation, and that gives me information about what has been deformed how. Let's just quickly preview this with the new preview functionality. Oh yeah, I should mention I'm using Blender 3.4, so it's the latest master version. And if I enable overlays, oh no, pie menu is missing. You can see that depending on how strong I deform this, the areas that are being compressed are getting more dark and gray. So this, of course, is a much more crude variant of what I showed you earlier, but that's the essential idea. Right. So that was the part about the attribute pipeline. Now, let's talk about hacks. So that's something that's, in my opinion, actually a pretty interesting category because that's something that you need all the time. It's just quick hacks just to get something done. As long as it works, it works. It's not fancy, you can't reuse it anywhere necessarily, sometimes you can. But it's just a quick solution to solve some annoying issue. And the fact that geometry nodes give you such low-level access to the data that you're working with in a visual representation just gives you so much freedom to apply hacks, for example. Here's just a simple example I wanted to share because I use that all the time with our characters. Just add a new geometry modifier. It's just one node. Oh, just a switch node. Sometimes you don't want to delete the default cube, sometimes you want to keep it around. So with this switch, you can just turn it off or on. It's like Schrödinger's cube or something. So the reason why this is useful is that you now have a control over whether this object is visible or not. That is not the actual visibility settings. Because those you have to manage in terms of, okay, this is viewport visibility, there's rendering visibility. But if you have a character variation that just shouldn't show up regardless of viewport or rendering, sometimes it's more difficult to manage that if you have to put that in all the different settings. So that's a very stupid solution to an annoying issue. And there it's gone. Poor cube. Right. That's the hacks. Now, a little bit more fancy and flashy examples, creative tools or generators. It's something to speed up the creative tasks that you were working with, to simplify some issues that you need to automate, right? It's the generators that you know where you draw a curve and then fantastic things happen. So here, one example I have is something that we used a lot for the groom of our main character, where it's just a simple tool that's part of the creative process to just make things easier. And here it's just adding some noise. So with the old particle system, you could do that on the fly, and hopefully we integrate more. The plan is to integrate more tools to also make that easily accessible to users. But right now, even though nobody spent time actually implementing these functionalities specifically for hair grooming, it's already possible because everything is compatible with geometry nodes. And in this example here, you can just add some noise. And what we do a lot with the groom here would just be to just apply it. It's just a tool. You use it one time, you apply it, and then you can continue with the groom on top of what you generated. And it's a procedural workflow in the sense that you can automate a lot of the things that you would otherwise have to do manually, but it's a destructive workflow also. And sometimes that's just what you need. Another example for the creative tools would be drawing in curves to generate things, like here meshes. You have the example where I had a task where I needed to create paint splashes, and I just very quickly made this tool to just paint, just get these splashes around. And it's really quick to do. You can just go in, let's open I'm used to the pie menus. You can just change things around, delete parts of it again, and the manual input that you're still using for the output, you have still a lot of creative control over the output, but you're not actually working on the output itself. So it's a lot faster to iterate on. That's incredibly valuable for any artist, I would say. Another example in a similar vein, a name tag with some stitching on it. Any Icelanders in the audience? I saw one there. Also, just using curves to create some embroidery. Let's just go in here. Well, actually, let me split this viewport so we can see it 2 times. I can just go in, grab my pen. Oh, why is it over there? Oh God, it's the wrong ZDef. Like this. There we go. So again, really quick to iterate. You can just draw something in. If you don't like it, you can edit it. Just go back. And yeah, this modifier is just using the input curve. I can show the node tree a little bit. Sorry, I'm not finding the right one right away. There it is. I'm using the input curve. You saw me draw it in, very simple. And then resampling the curve to generate a whole bunch of points along that curve. Maybe I can show the points with the preview. Right. So I show the input here. You can see that now there's a certain distance between the points, like here on the circles. Because before, if I just disable this, maybe that's easier to show. You can see there's a very, very different density of points here on these circles, and then there's nothing here. So I want to resample it to get a consistent density. Then this one just adjusts the shape to make sure I have nice round corners, the fillet curve. And then on top of those points, I just scatter a bunch of these smaller threads, these stitching elements, and then add some randomization, and that's about it. But there's more going on in this example, and that brings me to my next category, which is technical tools. So these were the artistic tools. Changed the user interface a little bit too much. These were the artistic tools, creative tools. And great, I'm a shading artist. I thought it might be nice to add this detail in geometry, because then we don't have issues when you look from the side at it, and we have highly close-up details, and looks much nicer. But then the rigging artist comes in and says, okay, now this actually has to work with the character. So in this example, because it's all curves, it can be a little bit tricky to actually make that work. Like you have things like surface deform, or can actually weight paint everything, but all those things have problems. So this we can also do in geometry nodes. In this example here, you saw that already. It looked a bit strange, maybe how the way I was painting this in was like completely detached from where it actually is. You can bring that back. And the reason for that is I'm actually drawing in these curves in the UV space of this object. So if I move this around, you can see it's actually attached all the time and even wraps around to the back, because it's using the UV coordinates of where I'm painting it in to project it onto the mesh. And that's pretty useful for details like this. That even means I can play around with this thing, I can scale it up, rotate it around, I can even go into edit mode. It's not just like parenting. Get this face, scale it down, and it's like a texture. It's using the actual UVs to project the geometry. That's pretty useful. This example also is a little bit too complicated maybe to show the whole thing, but I want to go into a little bit of explanation on this. Right, so this is already the right modifier. And the main player here is this node. It's the sample UV surface node. And what this node does is it takes a target input, which in this case is the mesh of this badge, but the modifier itself is on the curves themselves, because those I wanted to form along that target. And what I'm sampling with this sample UV surface node is the position of this mesh at a certain point in its UV space. And that's what that node allows me. I just obviously need a UV map, which I can just input here. Call that the stitching UV map. Just show this real quick. So this is what this UV map looks like, and now you can kind of see, okay, this is the square where it's from 0 to 1, right? So if it's here in this corner, that's where it is. And even if I just edit the UVs now, you can see how everything just keeps working in the way that I'm changing it. And this UV map I have to use as an input, of course. And then I compare it with, or I sample the mesh with this as the source UV map along a sample UV. And this is just the position of this object in this case. The position attribute. And that way I can actually just place it somewhere in the correct UV space and then project it onto the mesh. Maybe I'll do one thing to actually visualize this a little bit better, because I see how this is a little bit abstract. Just create a new plane with a new geometry nodes modifier. And then I'm going to take this object, which is the target object, just drag that in here. Just a very, very sloppy, quick setup. I haven't named a single node, so don't really take my my workflow as an example. I'm trying to be quick. And then I can use a set position node to deform this and to actually visualize how the UV space looks for my curves here. I can just set the position to the UVs directly. So remember, the map was stitching, and there it is. It's a little bit, it's overlapping with itself, and the reason for that is that the UVs at the seams are not split up, so now I need to just go in and add a split edge node. And there we go. So you can see this is the actual object that I'm projecting this on, flattened in its own UV space. And that's pretty useful now, because now I can actually see what I'm doing and draw in directly on the flattened version. And it's projected into the same position that I can see here represented. Okay. Let's get rid of this. I'm not sure if I'm moving too fast. In my last test, I was way over time, so I'm trying to be a little bit quick. Right. Another technical tool I just wanted to show relatively quickly. This here we used for fixing the tilt of a curve, because we had the issue with a moving character that as soon as you put some hooks to the curve and then move it around, the curve goes all over the place and it's just freaking out. So here, I just made a relatively simple modifier to make sure that the tilt of the curves at the beginning and the end stays fixed. Let me just show you how that looks without. Yeah, you can see it's just doing what it wants. So it's a relatively that's something where geometry nodes can really shine, because you have full control over the actual geometry itself. And the way this works is also, it uses some vector math, like there is in these node groups, there's a little bit of vector math going on. So if you're scared of that, then yeah, rigging is maybe not your forte, but the way this works is that I use some empties, one at the tip and one at the end. Just turn off this here. And then from these empties, I calculate with a little bit of vector math how the curve needs to be oriented, how the tilt needs to be to actually follow this. I do that at the end and the tip, and then interpolate between them. So there's the map range node here, which just uses the spline parameter input, which goes from 0 to 1 along the spline. And then I map that to the actual values that the tilt needs to be at the beginning and the end, and set that at the curve tilt, and then it works. And you can see if I just rotate this around, you can see how it nicely follows along. And then this empty can just be parented to the object. Right. So just to summarize a little bit for this category, the low-level access that you gain with geometry nodes is just giving you a lot of freedom and control of how to fix issues in these kinds of senses, where otherwise you're very restricted with the tools that you have in Blender already. And it's fully integrated into the modifier stack, so it works together with what you already have. Right. Now, my last category, which is probably most cool one, I've been looking forward to this one. Trying to use the pie menu every time. Parametric assets. You can have something like an effects asset like this that is generated procedurally or semi-procedurally, and you can just give it a whole bunch of parameters that you can tweak then on a shot basis. So wherever you use it, you can give it different parameters and tweak it directly to exactly you need it to do. And this one here is one that we have been using a lot for the current production. Oh yeah, take a quick look behind the scenes. So these are all cards. So it's not actually a volume. You could also do that with a volume in geometry nodes, but you've been using cards. And the idea is to just generate a whole bunch of trajectories and then put some asset on it, like sparks or debris or these volume cards. And the concept behind all of these different elements of this effect is all the same idea. It's all just trajectories, and you send the projectile along the trajectory. But the trajectories are all generated procedurally with these settings here. And you can also package that up in a way that you have a single asset that then, find the right object, is controlled with some custom properties here that you can then use to drive the geometry nodes settings, for example. So here, I can also then change the speed to be like in super slow motion or something like that. And you get all the subframes because everything is procedurally generated on the fly. So whatever parameter you put in, that's what you get. If that's like a little microsecond away from a full frame, then you can still get that. Right, for this one I also want to go just over one node that makes this possible, basically. You just figure out the right object. So these are the sparks, for example. But again, they're all using the trajectories. They're just sending different objects on top of it and have slightly tweaked parameters to fit their physicality a little bit better. Like the sparks are much lighter than the debris, etc. But the main node that's making the trajectories themselves possible is the accumulate field node. And this one is a little bit abstract to understand, and it might not seem super useful at first, but once you get a hang of using it, it's really, really powerful. And what it does is it takes any input field, can change the type of field here and the domain, and then it takes a group index and then accumulates the values of this field whenever it's being actually evaluated. So here is the next time that the geometry is actually used with this whole field. So this is where it's actually evaluated. And it uses the elements of this geometry, which I can just show you really quickly, is, okay, which one? Right. I can't really show you exactly because these are tiny curves. They're very small. They don't have an actual trajectory yet. That's where we're going. But I'm essentially generating curves with a certain amount of points. Doesn't matter their shape, because the shape is then going to be generated with this field. And the way this works, a little bit of physics. When you calculate a trajectory, you can just sum up the velocity over, because I separate it into individual steps, and then sum up their direction to get the location of the last point. But that last point is influenced by all the points before. So I can't just set it directly. I need to accumulate the individual positions or directions where they're flying from all the points before. And that's exactly what the accumulate field node does. It actually takes the elements in the geometry and then sums up to the current element all the ones before within the same group. And that's really useful because that means I can have a bunch of trajectories. Each trajectory has its own group index, and then within that group index I go through all the points and get the current position. That's essentially how that works. Of course, it goes a little bit more into detail, but yeah, like I said, I wanted to show multiple things. All right, we have 12 more minutes. Going from this, very similar. Go back here. Another parametric asset, also based on the curves. I have a bunch of smoke. If I go, sorry, not based on the curves, on the cards, the same way. It's just using geometry nodes to spawn a whole bunch of instances of a simple plane, and then using some shading to give that a little bit of a volumetric feel. But the trick here, to give that a little bit of variety and make it look a little bit more natural, is to, within the geometry node system, send over information of the life cycle of a single card into the shader. So you can actually animate this. And you can see, okay, because playing back in real time, it's a little bit noisy, but there's some animation. There's a sprite sheet animation on each one of those cards. And let me just go to the geometry node setup. Okay, this one is a little bit big. Yeah, sorry, I didn't really clean this one up for the presentation. But the essential idea is that I can pass out this is the main part that I want to focus on now. I pass out an ID attribute, which identifies each individual card, so I can introduce randomization. And I pass out the age, which you might be familiar also with the old particle system. There was a similar idea. You might want to use the age of a particle within a shader to give it, like for the sparks also I'm using the same thing, for example, where the sparks as they're just starting out, they're very bright and yellowish, and then glow out to be more red and then darker. And this you can do very easily with an asset that you already created in geometry nodes, just pass out information. And also relatively newly, I think I'm also using this here. So just maybe as a disclaimer, now you can even use attributes on instances directly from geometry nodes. So yeah, previously we'd have to realize the geometry, but now these cards are all using the exact same plane. They're just instances, but they all can have their individual age value and ID value assigned and used in the shader, even though they're all using the same base geometry. That makes it a lot more performant because you don't have to handle thousands of vertices. It's actually just instances. And when you go on from smoke, there's not a long way to also do some fire. So this is an example of using the same setup, just different sprite sheets, different shader, very similar setup. And then the only difference is I have a material, a node here that actually assigns the material, and I just change the shader. I can find the smoke. There we go. Oh, different smoke. It looks a bit worse. Sorry. Let's go back. And then lastly, once you have stuff flying on trajectories and you have a fire, what else is an explosion rather than just fire on trajectories, right? So with the setup of just combining the trajectories from the effects that I showed in the beginning of this category, and then just using the same setup with the fire on top of that to generate flames from the projectile that's shooting on the trajectory, you can get an explosion like this. And you prove that this is all procedural to just change some parameters. Some nice variation to it. Make fireworks. At some point the computer slows down, but that's essentially what I was getting at. And yeah, I'm actually really surprised that I made it this far already and I'm still under time, so that's pretty much what I wanted to show. But it also means that we can have maybe some questions. Yeah, go ahead.
Can we download this blend file?
This blend file, unfortunately not, no, but most of these examples, if not all of them, I don't want to lie, are taken directly from, based on what I've been doing on the current project, Project Heist in the Blender Studio. And we're always, every week, we do a production log and share all the stuff that we've been doing in the previous week. So that's part of the Blender Studio package. It's $10 a month. It's part of that. And some of these files are also downloadable for free, I think, but yeah, it's part of that. Yeah?
You showed that you can show the tension of a face and compare it to its undeformed state.
Mm-hmm.
Could we put an armature modifier in between the two geometry nodes and then still have the possibility to compare the deformed mesh to its original state?
You can do absolutely anything you want in between.
Perfect. So I could, can I export that as a map or as vertex colors, or so I can use it in text string? The idea is I have torsion somewhere and then I want wrinkles where it's less torsion.
Yeah, I can go back to the example. That's basically exactly what I've been doing. I've been using it in the shader. Where did I have it? Here. Okay, now I turn this off. Here it is. So the wrinkles that are created here are all just in the shading. And the way this works is by outputting maps like this. Well, maps, the attributes. So they're stored on the geometry. You can also bake them into maps if you want to. But because you can use the attributes directly in the shader, you can just do it like this, for example. And yeah, here I've been using multiple different maps at the same time to also get the direction of the stretching, for example. Oh yeah, I didn't show this. I wanted to show this, but here, this is basically the map. So you can see the influence of the deformation.
149.
Right. Yeah, that's also a little bit of kind of the point that I wanted to make. Some of these you might say, okay, isn't it just trying to replace some functionality that Blender should have on its own? Maybe. But is that so bad that you're already able to do these things? And the things that should definitely be in Blender, we would also agree that they should be. They will make it eventually, but doing that on the scale of implementing it into a software is very different from making your own little tool. You can do that on a much shorter period of time because you don't have to make sure that it works with everything else and maintain it. You can just use it by yourself or share it with other people. But yeah, that's what I would say to that. Some of these things definitely could also just be part of Blender from scratch. And also some of these things are planned to be inside of Blender as node group assets that we're planning to ship with Blender at some point. But that's an ongoing process. Yep. Mm-hmm.
Thank you for the presentation. So for geometry node, you can also do like more simple particle systems, yeah?
Mm-hmm.
And I'm wondering, it's a very naive question, what are the differences of efficiency, performance between the old particle system and I don't know if you remember that?
I personally don't have made experience with that, to be honest. I don't know if there's a difference. Oh, we're getting shut out. There's going to be, oh yeah, that's also something I wanted to mention. There's going to be another session. I forgot when it is, but there's one of the developers, so maybe you can answer. There's going to be a session by the main developers of geometry nodes in the developer attic. So maybe that's a question that can be better there. Yeah, and then maybe you can wrap it up. Thank you for your attention.